Hello guys, kumusta kayo? We are here in our subject, Machine Design 1. Our topic for today is Tolerance and Allowances. This is the third chapter of the course outline. We are already finished with the analysis of simple stresses and materials and their properties. So for this topic, our objective is that the student should have adequate knowledge on how to apply and specify tolerance in a machine part. So when we say tolerance, it is the permissible variation of the size of a dimension. So tolerance may be bilateral or unilateral. Bilateral is when the size of a part is permitted to be either larger or smaller than the given dimension. Example niyan is itong nandito sa baba, 9/16 plus or minus 1/32. Ibig sabihin niyan, pwede siyang tumaas ng 1/32 dito sa 9/16 or pwede rin siyang bumaba ng 1/32 of an inch. Kaya tinawag siyang bilateral. Pwede siyang tumaas at pwedeng bumaba. Dito naman sa unilateral, the size of part may be larger only or smaller only. So halimbawa ng unilateral tolerance, halimbawa meron kang 1.062 nominal size. We say nominal size. So pag unilateral, dapat pwede siyang lumiit or pwede siyang tumaas lang. So halimbawa dito 1.0062 plus 0.010 of an inch. So pwede siyang lumaki at dito naman ay pwede rin siyang lumiit. So isa lang, one way. It's either pwede siyang lumaki or pwede rin siyang lumiit lang. Samantalang sa bilateral, plus or minus 0.010. Pwede siyang lumaki at pwede siyang lumiit sa 1.062 nominal size. Unilateral tolerances are generally used on those dimensions involved in feet such as a pin and a hole. So sa pin and hole kasi, dapat unilateral yung tolerance niya. Ang hole ay dapat pwede lang siyang lumaki, hindi siya pwedeng lumiit. At yun namang pin ay pwede lang siyang lumiit, hindi siya pwedeng lumaki dun sa nominal size. Kaya unilateral lang. So ang allowance naman, the definition of allowance, it is the difference in size in which for running fits. So sa running fits, it is the minimum specified difference between the dimension of the pin and the hole. So, minimum specified difference between the dimension of the pin and the hole. Yun ang allowance. Tatandaan nyo ito, minimum. Allowance may be positive if the hole is larger than the pin. So, halimbawa itong dalawa, positive allowance to. Kasi yung hole ay mas malaki kaysa sa pin. So, may allowance siya positive. Allowance may be negative if the pin is larger than the hole, or yung tinatawag nating interference fit. Yung pin or the shaft is larger than the hub or the hole. Pag pinasok mo yan dito yung shaft sa hub or sa hole, masikip yan, interference yan. Negative yung allowance niya. So when we study about fits, meron tayong iba-ibang klase ng fit. So as you can see in this slide, there is closed sliding fits RC1. This type of fit shows no perceptible play. Ibig sabihin nito ay masikip ito, walang play. RC2, which is defined as the sliding fits, this fit turns and move easily but are not intended to run freely. So maluwag konti pero hindi siya mapipihit na freely. RC3 precision running fits for precision assemblies operating at low speed, light load, and small temperature change. Ito ay nakaiikot niya na. Okay, nakakaikot na yung shaft. Pero low speed lang. Medyo masikip pa ito konti kasi precision siya . Close running fits RC4 for minimum play, moderate speed, and temperature rise. So, para sa may mga moderate speed and moderate temperature rise, at minimum play, ang kailangan mo ay yung close running fits. Minimum play, meron siyang konting play na maluwag-luwag ng konti. RC5 and R6, this is RC6. Medium running pitch, this is for higher speed and heavy journal pressure. So, mas maluwag siya ng konti kaysa sa RC4. Pwede na siya sa higher speeds and heavy journal pressure. Ibig sabihin ng heavy journal pressure, may load siya, pwede dun sa may mga loaded yung shaft. Kaya may journal pressure siya. RC7, free running pitch for large temperature variations in wide tolerances are permissible. Yung kasing yung tolerance ay minsan kaya maluwag yung fit, maluwag yung shaft dun sa hub. Kasi kung minsan dun sa application yung nagkakaroon siya ng high temperature. Kasi yung high temperature kasi magi-expand yung shaft. Dito kasi sa free running pitch, ito yung for large temperature variation, yung temperature na matataas, yung umiinit, kailangan niya ng wider tolerance kasi nag-expand yung bakal, yung shaft. So, hindi siya maapektuhan. Yung kahit nag-expand na siya ay maluwag pa rin. RC8 and RC9, ito naman yung pinaka maluwag, loose running pitch for use with commercially rolled shafts and tubing. So, makikita nyo dito, yung RC1 to RC9, masikip dito ay maluwag na siya. Paluwag yung yung direction niya. So sa table 3.1 of our textbook, Design of Machine Elements, makikita niyo dito yung mga type of tolerances, yung mga different brackets ng tolerance. Halimbawa, ang nominal size, okay, ito yung first column is the nominal size. Halimbawa, 1 inch yung shaft mo. So, mapatak yan dito sa 0.71 to 1.19. Halimbawa naman, 1.5 inch ang shaft mo, ang dimension ng shaft. So, dito yan sa 1.19 to 1.97. Kasi 1.5 lang siya. So, kung 0.5 naman, mapatak naman yan dito sa 0.4 to 0.71. Ngayon, ito yung class RC1, RC2, RC3, RC4. Ito na yung diniscuss natin previously. So, for hole, ito yung tolerance niya. Plus 2, 0. Ang shaft naman, negative 0.1, negative 0.25. Kung RC1 ka, at nandito yung bracket mo. Kung sa 1 inch ka, nandito naman. So, ito yung plus or minus na inalagay sa hole and shaft. So, ito yung continuation. RC5, RC6, 7, 8, and 9. So, makikita mo pa rin dito yung range ng shaft ng dimension. Hanggang 12.41 inch. So, makikita mo dito yung mga tolerances niya. Plus 8, 0. Minus 12, minus 17. So, this is thousands of an inch. Ang basa dito ay thousands of an inch. Pag binasa mo siya ng 12, ibig sabihin niya is 0.012. Okay? Pag binasa mo siya ng 5, ibig sabihin niya ay 0.005. This is thousand of an inch. Kung babalikan natin dito, nandito yan sa heading niya. Nakikita niyo dito, multiply by 10 raised to negative 3. So, thousands. Or divided by 1,000. Kaya sabi ko nga, kung ang nakalagay dyan ay 0.2, so 0.0002 yan. 0.5, 0.0005 yan. Ganon. Kung 2.0, ito 2, so 0.002 yan. I-divide mo siya ng 1,000. Example, given 7/8 inch pin on its mating hole. So, may given siya, meron tayong na-compute na dimension. Yung pin dimension is 7/8 inches on its mating hole. Pag sinabi mong mating hole, yung kapares niyang butas. So, how much larger than the pin must the hole be, assuming loose running fit RC9? So, ang solusyon niyan, convert muna natin yung 7/8 inch to decimal form 0.875 yan. So for whole, mayroon tayong 0.005. Saan nakuha itong 0.005 na ito? Ito yung tolerance natin. Plus 0.005 and plus 0. So makukuha natin yan dito sa RC9. Hahanapin mo yung 0.875 dun sa table. So kung makita mo, yung 0.875, mapatak yan dito sa between 0.71 at 1.19 kasi 0.875 siya. At kukunin mo yung RC9, ito. So ito yung para sa whole, di ba? Para sa butas, 5.0 or 0.005 and 0. Kaya meron tayo dito na 0.005 kaya kasi yung 5.0 is divided by 1,000. So i-add mo yan, that becomes 0.880. 8.875 plus 0.005 is equal to 0.880. So this is your maximum dimension. Ngayon, yung isang tolerance niya is one way siya, di ba? Unilateral. So plus 0, mananatili siya. So ang dimension ng whole mo, ang minimum niya is 0.875, ang maximum niya is 0.880. Ang tolerance niya is 0.005. Isusubtract mo tong maximum minus minimum. So ang tolerance niya is 0.005. Para lang din dito, pag sinubtract mo tong dalawa, 0.005 minus 0, 0.005 din. So ganun lang yan, maximum minus minimum. Yun ang whole tolerance. For shaft naman, makikita naman natin dito yung negative 0.007 and negative 0.0105. Kung titingnan natin dun sa graph, nandito siya, RC9 and 0.875 nandito. So, nandito is negative 7. Sabi ko nga, i-divide mo sa 1,000. That is negative 0.007. You move the decimal place 3 to the left. Okay, itong 10.5 magiging siyang 0.0105. Yan, 0.0105 yung 10.5 doon. Ito naman yung 7. So, ang maximum niya is 0.868, ang minimum is 0.8645. Or ang shaft tolerance, pag sinubtract mo yung maximum minus minimum, 0.0035. Makukuha mo rin yan kung isa-subtract mo yan itong dalawang ito. So, the question is, ano yung allowance? How much larger than the pin must the hole be? So, ang hinahanap dito yung allowance, di ba? How much larger than the pin must the hole be? Yung comparison. So, ito yung allowance, the minimum of hole, minimum dimension of hole, which is 0.875 minus maximum of the shaft, 0.868. Natural naman kasi minimum ng hole minus maximum ng shaft, yung pinakamaliit na hole, tapos pinakamalaking dimension ng shaft, yun ang allowance. Kasi yung definition ng allowance natin is, kung babalikan natin yung definition ng allowance, ang sabi dito sa definition ng allowance ay the difference in the size in which for running pitch it is the minimum specified difference between the dimensions of the pin in the hole. Tingnan nyo, minimum specified difference. Kaya ganun ang naging solution dyan dito sa problem. So ito na minimum. Otherwise, kung gagamitin mong ibang dimension, makakakuha ka ng more than 0.007 na difference, which is not the minimum. The minimum is 0.007 inch. Yun ang allowance. So the methods of dimensioning, ito, application nito sa, kung maglalagay ka na sa dimension sa drawing mo ng dimension, ganito dapat. May dalawang paraan, pwedeng ganito, pwedeng ganyan. So, yung hole natin is 0.875. Okay. Ibig sabihin nito, ito yung minimum na dimension ng hole, 0.875, at yung maximum niya, 0.880. So, inahin mo yung sa hole, yung minimum. Ito naman sa shaft, yung maximum ang unahin mo nasa itaas, 0.868. Ito naman yung minimum niya. Baliktad sila. Dito sa hole, yung minimum ang nasa itaas, at sa shaft naman, yung maximum ang nasa itaas. Ito kasi yung target ng machinist niyan. Itong 0.875 at 0.868. Para magkaroon ka ng allowance na minimum na 0.007. So, tatandaan niyo yan, guys. Pwede naman ganito. Ito yung hole, ito yung ano niya, 0.875 plus 0.005. Ito yung nabasa natin sa table. Diba, ito yon. Ganito, pwede siyang ganito ang style ng, alam na ng machinist kung anong ibig sabihin yan. So, pwedeng ganito at pwede rin ganyan. Now, let's go to press and shrink fits. Ang sabi dito, when the hole is smaller than the shaft, nabanggit ko na ito kanina, it will take force or pressure to put the cold parts together. The allowance is said to be negative. Shrink fits and is termed interference of metal I. Ito yung allowance, ito yung I. Mamaya, makita nyo kung saan ginagamit yung I. Interference. Yung difference yan. Okay, ito yung na-compute natin na minimum difference. Okay, minimum difference. It is equal to I. Allowance is equal to I. When dealing with shrink fits. Makita nyo sa figure, mas malaki yung pin kaysa sa hole. This is the negative allowance or the interference I. So, meron ding table siya, yung force and shrink fits, interference fits. Ganon din. Meron din siyang class, FN1, FN2, FN3, up to FN5. At meron din siyang ranges ng dimension. So, halimbawa, 1 inch, nandito siya sa 0.95 to 1.19. Ang 0.5 inches, nandito siya sa 0.4 to 0.56. So, ito naman yung hole in shaft uli. So, same lang yan nung kanina, yung sa table ng tinignan natin. Ayan, ito pa yung continuation. So, for example again, given 1 inch pin on its beating hole, determine the dimension of hole in shaft using class FN3. So, solution for 1 inch nominal size for hole, that is, meron tayong tolerance na 0.008 and 0. Tingnan natin. Class FN3. So, 1 inch siya, nandito yung 1 inch between 0.95 and 1.19. At yun namang FN3 nandyan. So, we have here 0.8 and 0. So, since 0.8 and 0, didivide mo sa 1,000 yung 0.8, magiging siyang 0.008. So, 1 plus, kasi positive siya. So, 1.008. That is maximum of hole. So, 0 yung ano. So, 1 minus 0 is 1.0 minimum. So, the hole tolerance is 0.008. For shaft naman, meron tayong 0.0021 and 0.0016. So, kung makikita natin uli dun sa graph, nandito siya. 2.1 divided by 1,000, 0.0021. 1.6 divided by 1,000, that is 0.0016. Kaya ang nandito sa atin ay ito na, 0.0021 and 0.0016. So, pag inad mo siya sa 1, magiging siyang 1.0021 and so on. The shaft tolerance is 0.005. Ngayon, ito yung allowance, di ba? Yung I, interference na siya kasi negative na. The minimum dimension of hole, 1 minus the maximum of shaft, 1.0021. So this one, 1.0 minus 1.0021, magkakaroon siya ng negative 0.0021 is negative allowance, interference. Ito yung value ng I, interference of metal, I. Ito kasing I ay ginagamit yan dun sa stresses due to interference of metal. Yan. So sabi dito, the tight fits may produce large bursting pressure on the part of the hole. Pag sinabi mong bursting pressure, yung hole, yung hub, pwede siyang mag-break. Kasi pag pinilit mong ipinasok yan, tight, pwede siyang mabasag, yung mag-burst. The stresses in the hub can be estimated with reasonable accuracy from the thick cylinder equation. Meron tayong equations of thin cylinder, thin-walled cylinder. Meron ding equation ang thick-walled cylinder. So, pwede natin i-apply yan dito, yung thick-walled cylinder. For a quick check, on the safe side, one can assume that the shaft is rigid and all the deformation occurs in the hub. So, pwede naman sa ating i-assume dito, for quick check lang ng stresses. Assume natin yung shaft is rigid, hindi siya na-deform pag pinasok mo. at yung hub ang na-deform. So, we have this equation, S is equal to EI divided by D, where S is the stress in PSI or PSI, kung anong value ng E. So, yung I is interference in inches, yung nag-compute natin kanina, yun yung I. Ito yung I, negative allowance. So, D, hole or hub diameter in inches. Dito. Hindi yung shaft, ha? Yung hub diameter or hole diameter in inches. And E is the modulus of elasticity of the material of the hub in PSI or KSI. So, makukumpute mo yung S. So, kung maluwag naman kasi, wala namang stress yan. Diba? Kung yung doon ka sa mga loose running pits, walang stress doon kasi maluwag. Pero pag interference pit or the shrink pit, meron talagang stress yan sa hole. Usually nga, nagkukos pa yan ng breakdown ng hole pag sobrang masikip yung shaft. So, yun muna guys ang ating lecture dito sa tolerance and allowance. At sa tingin ko naman ay hindi naman ito masyadong mahirap na topic. Meron ka lang tatandaan ditong mga kunting computations, marunong ka lang magbasa ng mga chart and tables, ay madali makukuha itong topic na ito. Okay guys, salamat.